we have something that's kind of interesting to show you today. We had a lot of fun. Garrett and I had a lot of fun going back and forth figuring out all these new things. So what we did, what I have up here on the screen is not AutoCAD, if you've noticed. What I have up on the screen is a program called Inkscape. It's free, it's open source, and you can download it off the internet. And what I'm going to do with Inkscape is I'm going to take an image and we're going to vectorize it. We're going to get line work out of an image, and then we're going to take that image to DXF, open it in CAD, or we can open that DXF in CAM and ultimately produce this image, burn it out on the plasma table. So what we want to do is just walk through those steps and show you what we have. So I'm going to go ahead and open this image. Let's see here. It's on my desktop.
It's football season.
There we go. Okay. Football. I do apologize for that. There we go. Okay. So this is just an image I downloaded off the internet. I didn't do anything special to it. Obviously, it is in black and white. If you're going to do something like this, black and white images is definitely the best way to go. So I'm going to use this. I'm going to click on the image, right-click, and go to Trace Bitmap. And there's some options here that you can get a more optimized result of the tracing. I think this by default comes in at like 0.4. I found a better result when I upped it to about 0.45. So I'm going to hit OK. I'm going to hit Update, close this, and now I'm going to move this off to the side. Now we have two footballs. And I'm going to turn on these Edit Paths by Nodes over here on the left side. You guys can see my mouse there. I'm going to turn that on. All right, so now what you can see here is these grips. So this is pretty similar to what we see in AutoCAD. That's what we're looking for. So let's get rid of this football, and we'll move this one back over here. All right, so basically what we did, we just vectorized that image. I'm going to save this as a DXF file. There we go. Something that we can open in AutoCAD. I'm going to save it here. Here we go. All right. I'm going to replace it. All right, so now that I've got that, I'm going to open my AutoCAD, and I'm going to open that DXF. All right. Pretty cool. Now I got line work. Okay? All right. So now I can, this gives me a chance to clean this up. Obviously, I don't want a cut there, so I can just use the regular trim command. Clean that up. Clean that. All right. Get rid of this stuff here. All right. Okay. You can, maybe you don't want that to be that way. You can just delete and grab that node, marry it up like that. That didn't work. Let's go back. Grab the wrong node. There we go. And let's do this one. All right, now let's do, I said we don't want it to come in at
711 inches. It's like 35 feet.
There we go. Yeah, so let's get this thing to be square. I'm using the align command here. I'm going to snap that point to the straight line. I'm going to snap that point to the straight line and straighten that out. All right, now let's scale it down because we want to burn this thing out in 12 inches. Okay, so we'll scale that reference, take that length, and we'll say 12. All right. Okay, so here's my pattern. Pretty easy. And what else I'm going to do is I'm going to insert a block that has some information There we go. All right. And I'm going to put the laces on we'll say we don't want to cut out the laces, so we're going to ignore the laces. Get the color there. There we go. And then we want to select everything else. And we'll put that on the cutting layer. Forgot to set it to select previous. And we will set that layer. Okay, so now we have some, I'm going to get rid of these because I don't want to actually cut a line there. We have some information here. The material, we want this material to be galvanized. And this is the gauge. And we want to do 20 of these. So I've got this image vectorized and cleaned up pretty short and sweet. And I'm going to go ahead and hit save. And I'm going to save it in the same location. And what I'm going to do is I'm going to pass this off to our cam guy, and he's going to produce this. So, Garrett, I'm going to let you take it away.
All right, David. I'll wait on the control here to get to me, and then I'll start to share my screen. All right. Can everybody see my screen there? All right. So I was just sitting over here playing with some other technical stuff while David was doing his part. So I assume what David has done is he's gotten a football ready, and me being the shop, he's ready to have that produced. So the first thing that I want to take note of before I start moving around within the program is a lot of people may only have AutoCAD. A lot of people may only have CamDuct or some form of a manufacturing software. One thing that is pretty much a global constant is your hardware, or at least your fabrication software, not necessarily CAM, whether it's Vicon, whatever it may be, you're going to have the ability to import a DXF. But with David preparing the layers inside of AutoCAD, it doesn't even necessarily have to be fabrication. He was creating those layers inside of AutoCAD. That layer information that he assigned, so the outside being green, the inside being blue, as far as the colors, you could dictate what's cut, what's processed, what's ignored. So I'm going to go ahead and I'm going to go File, Import Items. And here's his football, I assume. Give this double click. So notice that this ignore layer is blue. Okay. The material here is galvanized. The gauge is 033, that's 22 gauge roughly, and a quantity of 20. So he's letting me know maybe he's doing cutouts for his kid's birthday party. I don't know, but he needs 20 of these at this size with this material, as well as this gauge. So because he already put that information in, I can simply hit OK. Notice that this was ignored. It's not there. It won't be processed. What's most important to me throughout this process is I'm just going to simply hit accept. I'm going to go ahead and open, or just bring that in. And what I want you to notice is the column here for quantity. There's 20 of these. The material is galvanized by 22. All of that information came from the DXF file. I did not specify or call out 20. It all came from David when he saved and stored that file. That information was brought over to me. Now, I know the name of this webinar, what was it, David? DXF import, part validation, and nesting, right? So we've done a DXF import, and we've validated the part. I'm going to go ahead and I'm going to nest it so that way we can say, hey, we did what we said we were going to do. But we're going to get a little bit deeper than that. It's a pretty straightforward process when importing these things. But now that we've nested it, we've done everything we said we were going to do, but we're going to get into the weeds a little bit more. All right. I'll let this just run all the way through here. I won't make you sit here and watch it. We'll just run it through. Notice that the laces weren't cut. I'm going to go ahead and run through that process one more time, just so I can show you a little bit of flexibility when you're bringing these things in. But before I do that, I want to enter the database. Under manufacturing, you have your layers. So if you, in AutoCAD, if you have a detailing department, such as David's my detailing department, I'm his shop for this scenario here, we have the same database, so we have these layers. If David sets up a template, or you have your user set up a template, they can set up layers inside of that template with the colors. As long as those layers are named the same, it will transfer over whenever the import happens. So this says display only, that's fine. Display only default cutting. That's just our layers. Now we have layer mapping. Notice that my ignore layer, whenever it's brought in, it comes to the ignore layer, and I have it set to ignore, which means I don't want anything. You could create an additional layer for marking, for example, if your table has that functionality. You can call out marks, you can call out cuts, just straight from a DXF. Now, the text attribute mappings. We're going to go back to CAD. I'll pull it up and we can talk about it, but this is just mtext. As long as in my database I have these texts or these values for the text, the program is going to search for anything coming from a DXF, for example, material equals, gauge equals, and quantity equals. And we've tied this to an attribute inside of the program. Now I've found that you actually fully need to spell the material. You need to put in the thickness for the thickness. You can't just put in 22. You need to put in the physical thickness that resides within your fabrication database for that given material's gauge, or for that gauge's thickness. I guess that makes a little bit more sense. So I'm going to go back into File, Import Items here, and we'll grab that football one more time. This time I actually want to cut these laces. So I can come down to the ignore layer and I can say, actually, I want you to process the elements. That's an element. It is not text. Go ahead and hit OK there. Now you can see that I have the laces. Another thing I want to show you is, for the beginning of the example, David went into AutoCAD. He cleaned up the image. He did some things. What happens if you don't have AutoCAD? What happens if you strictly have CamDuct and someone sent you that DXF? Of course, you do have the ability to do the same things. The same things that David was doing, you have the ability to do. So you can just snap, move, stretch, etc. However you need to do it. You have the cleanup tools in here. This is essentially R1 AutoCAD. You can scale it. Oh, well, if I could type right. Right. I know Fab. I don't know English very well. Pardon my typing abilities. So here, if I wanted to say I need it to be 24 by 24, notice that based off the scale that David applied to it, it tells me what my by needs to be. So if I want this to be 24, you'll notice that my new size over here will be automatically decided for me based off the overall geometry of the pattern. I'll just set this back down to 18. Hit OK. It should upsize a little bit. And again, when I hit accept, I'll validate the piece, right? It has everything. It's got 20, it's got 22. It's got everything that I requested it have when David sent it over to me. I'll go ahead and nest this so you can see that, well, the laces should have been cut. Let me verify. All right, so let me go through that again. Import items, we'll grab the football. Oh, unclean. Oh, that's the old one, football. Process. All right. And I can change this to the cutting layer as well. I'll just re-accept that piece. I'll nest this one here. Huh. That's interesting. I just went through this and it was fine. Maybe I'm missing a step when I'm doing the import. So File, Import, Items. Here's the football. All right. put this to cutting. Process. All right. And let's see if the laces nest this time. Nope, still not nesting. Okay.
Garrett, I'm wondering if it's reading from your database item. I think you saved the football in your folders.
Yeah, I believe I did a while back.
Maybe delete the one out of your folders and then bring it back in.
All right, but let me look at the tool here. There we go. Been missing one the whole time. Just change that layer to use the proper tool. It had just been ignoring it. Nope. It's a combination of all of those. So when I'm importing this item here, football, I need to set my tool name not to display. I need it to be default cutting. And I don't need to ignore the elements. Okay, so it's a combination of these three things. I had that stuck on display only and I didn't catch that. So now when I accept it, it should actually nest the laces. Still not. So let me see if, because see the one, my foosball there, David, it does have the laces in it.
I see that.
So that's odd there. Do I need to change the color as well? Okay, now it has laces. It just wasn't showing it. Okay. So it was a combination of those three things there. So inside of your database manufacturing, under layer mapping, you can set up as many layers as you may want. These are essentially what's going to come in from an outside source. So let's say that you work with David up the road and he does all your detailing and he likes to put things on his own layer, right? If something comes in on David, I can say what I want it to do as far as the map layer. So your map layer is displayed inside of layers. They're created only in fabrication. And this is essentially what stores what tool's being used. So if you had a marking layer, you could set it to marking. If you have the cutting layer, you can set it to cutting. And based off what layer a certain portion of a DXF is on when imported, it will automatically know what it needs to do with that layer, whether it's to ignore it, to cut it, to mark it, etc. Now, the text attribute mapping, this is key. It has to go in a certain way. It can't just be thrown in. Originally, when people said attribute mappings, the first thing that they think of is an defined attribute or an @def inside of CAD MEP or just straight AutoCAD. That's not the case. It's simply mtext. Your search text must be identical inside of that piece. So if I actually spelt out, or David, when he sent it over, spelt material equals, my search text would not have found that when it imported it. It only looks for MAT equals. So it must be identical. If you have a CAD department on fabrication CAD MEP and you're running CAMDuct, this will be the same. You can work with them, set it up, nothing will change. But if you have someone that is simply sending you straight AutoCAD DXF, they've never even heard of fabrication. They're still doing just AutoCAD drawings. They would need a screenshot of this so they would know what identifiers to put into their file when they're sending it to you. David, do you have CAD up so I don't have to launch it? And I mean, I'll talk if we can just throw it to your screen.
Yep, I have CAD up.
Do I need to change presenter to you?
No, I got it.
Okay. So
you see my screen?
Yeah, I can see it. So notice that he has MAT equals, GALV, GAU. All of my search text values are correct here. But one thing that I've noticed is you have to physically have the full material name, as I stated previously, as well as for gauge, the attribute in fabrication is thickness. It needs to be that material thickness. You can't put in 22. As well, that's all mtext. All we did there was do mtext. Well, you can do it all in one line. I think, David, you've done it on 2 separate lines, right?
I have it in 3 separate lines.
3 separate lines, right. So what I was thinking initially was, mtext is the identifier or the search text and then throw in an attribute definition. It's literally all in text. The only thing that you must keep in mind here, zoom out for me, David, is those 3 lines of in text must be enclosed by the pattern. So he couldn't go put it on one of the laces, right? So if you want to do that, throw it out there and go ahead and resave this and call it bad or something, and then I'll open it up. And I'll go ahead and steal the presenter role here. All right. So we'll do, I'll just delete this one. So we got bad football. I said bad football. I don't care about the layers there, so we'll hit OK. We'll hit accept. Galvanized 22. I guess that doesn't matter. Proved me wrong again. But I'm also in 17. Last time I tested with this was 2016. So maybe they've corrected that. But David, didn't we encounter an error with that prior?
I think I remember something similar. I don't know. I was under the impression it needed to be inside the bounding area.
Correct. Change the layer, though. I think that's a cause as well, because it's on that text layer, so it knows just to process that.
Yeah, if I put it on a 0 layer or some other layer that Fabrication Database isn't looking for,
right,
that'll definitely mess it up.
And so if we just do a normal import here of the just the clean one, notice that there's no layers there, right? So this is the original export that David did when we first got on the webinar today. He then opened this in CAD, came in and did his cleanup. I think that was all of them, right? So he came in, he did his cleanup. I think he got rid of, those there, the polyline, like that. Did his cleanup. But notice when I hit accept now, it's going to ask me to validate the piece. So I'm going to go ahead and validate the piece. It knows galvanized by 22. That's coming from my carryover values. But it doesn't know the quantity anymore because that information was not there. I could say 1, 2, however many. I'll just leave it at 1 for now. Here's the football unclean. Let's say that this is something that we use all the time. This is something that I'm going to continuously do. Maybe once a year, once every 3 months, I don't know. You can right-click and you can save it as a catalog. And that's where I had my foosball over here. I'll go ahead and overwrite foosball. All right. And so now it's in my item folders. If I double-click on it, I can go in and I can take it off. I can change the material, do whatever I need to do. If I want to change the dimensions, I can just right-click Edit. I'll be back within Opus and I can rescale it. I need to get out of the profiler. And so I could say, all right, let's do 24. Now it's scaled down. Because that original that you sent me just now, or I opened the original and it was still large. So go ahead and jump back to your screen, David, and let's show the layers that we have set up inside of AutoCAD. I mean, CAM really doesn't have layers other than inside of the layers and layer mapping windows that I was showing you. AutoCAD, you can create a drawing template with these layers predefined. I believe what David did for this scenario was David went ahead and created a block that had all of that information. So he inserts the block. The block has the layers, right? Is that right, David?
That's correct. What I did was I just created a DWG file with the information and the existing layers. Because when you bring this in from an outside source, these layers aren't going to exist. So the easiest, quickest way to get this in there is just to import this drawing as a block. So I'm just going to insert browse to that, and that'll bring in all the necessary layers and text for me to fill out. And I can go through and assign the colors and everything like that, like I did before. Pretty straightforward. I think we can turn this over to some questions if we have any. Do we have any questions?
Let me pull it up right now.
Confirm that I believe everything looks like Newman gave you the need to change tool tip, so definitely helping you out there.
Hold on, need to change a tooltip in
Yeah,
CAD?
that was around the same time you were searching and validating there.
When you were trying to get
Oh,
the
yeah.
latest.
Okay, so Newman caught it before I did. Nice, man.
Definitely did. Or at least around the same time.
Let me pull this out. Okay. I take it Newman's had to go through that a time or two.
Well, if nobody has any other questions, here in just a second we'll have a $25 Amazon gift card giveaway. Just complete the survey if you would. Take a few seconds to complete that. We'd appreciate it.
We do have a question coming in. Hold on, Matt. Does the DXF import work with polylines and lines alike? Troy, can you give me a little bit more information there? The DXF import should work with a polyline. You should be able to create a polyline, save it as a DXF. Are you more so referencing the import with the layers or just the import in general? No layers, no text.
These are splines right here. This is what came across from the, I believe we could convert these into polylines. Let's see. I don't know if we can convert. Specify precision. Here we go. I think I just made that into a, there we go. Okay, so that's a polyline. Let's delete this.
David, he said he's had issues in the past with polylines working properly. Maybe it's been fixed. He's also had issues with ellipses. They haven't worked in the past. Straight up.
Okay. Okay. So pulling the image in from the external program, Inkscape, it converted them to spline. As the AutoCAD read it as a spline. So, you know, we can try to run this. I just converted these laces to a polyline. We can see what happens. You definitely get a lot more nodes in there, and I can see that the calculations on your CAM software having an issue with that. Let me hit save. Garrett, if you want to pull that open and process that and see what happens.
Okay. Do I need to be presenter, or you just want me to relay it?
Let's go ahead and show your screen.
Which one is it? Football?
Yes.
That's what you saved it as, is football?
Yes.
Okay. Go ahead and open it. Do I need to share mine, or what?
Yes. Yeah, go ahead and share your screen.
All right.
That doesn't look the same as the one I just saved.
Okay, well, bear with me because I believe Joe Truitt was, I don't know, Joe, is yours more of a question, or would you like me to relay that information to Troy? Joe said they have made it easier. He's done this, but it's not an everyday thing. I did not know about the software to basically make the vectorized image, and thanks for the informative presentation. Newman, you're paying attention, man. David, it's bad football.
Newman is on it.
He knows better. He knows better than we do. Bad football.
It wasn't laces out.
Is that Ace Ventura? So what did you want me to do here? Just accept it? See how it goes?
Just go ahead and process it and see if it's working with the polylines.
Yeah, I mean, it seemed to have processed all just nest that one. All right. Yeah, seemed to work fine. Let's look and see if there's jaggedness. I mean, you can see sometimes, you will be able to see visually. Here's a little bit of a flare out. You can see it's not perfectly straight, but I mean, it's a football, you know, so it's got to have some kind of round character to it. Okay, it seemed to have worked fine there.